Welcome to Blue Pen Land. This is the first video I am going to make with my new computer. This is very exciting for me. All right, so unfortunately, the rotational motion problems tend to be weird problems like this. But anyway, let's just work through this thing. This is this rope is going to pull on the side of the cylinder there, right? And this bucket's going to accelerate down. And so I think what we got to do here is we got to identify the forces, right? So for the bucket, you've got the tension acting upward, right? You've got the force of gravity downward. That's mg, right? And so for the bucket, you set up an equation like this, right? Mg. Remember, we're going to guess that that'll accelerate down, right? So we need to make the acceleration positive. So mg is causing the acceleration. The tension in that string actually prevents the acceleration. So the bucket won't accelerate down as fast as 9.81, right? It'll accelerate down more slowly because of the tension. And then that equals ma. And what we're using here is F equals ma, right? So the sum of the forces acting on that bucket are gravity acting down and the tension acting up, right? And the gravity is well, actually, we make this guy positive, we make this guy negative, right? Because we want to make the direction of the acceleration positive, okay? So that's one equation, and sadly, we have to set up two equations, right? Because we don't know the tension and we don't know the acceleration, right? And we're trying to solve for the acceleration. So the next thing we want to do is we want to use the relationship that torque for this cylinder here, right? For the cylinder, right? For the cylinder, torque is I alpha. And this again is F equals ma. This stands in for F, right? This stands in for M, and this stands in for A. Okay. Now what we're going to do is we're going to substitute for this. We're going to substitute, remember torque is RF, right? So this is going to be, notice that they want us to use this big R. So you're going to go R times T, right? Yeah, the tension is the thing causing this thing to accelerate, right? So R times F becomes capital R times T, where T is just the force, right? Okay, and then for I, you're going to substitute 1/2. They tell you right here. Big M R squared. So keep in mind that this is small m, right? That's small m, that's this mass here, right? And then the bucket is, or the cylinder is big M, right? Okay, and then for this guy, we're going to substitute A over R. Okay, when you do that, you're going to get this beautiful little thing. You're going to get T is equal to, and this is easy. It's got M and it's got A. Okay, it's got this M in there, it's got A. The R's are going to cancel out, yeah, I don't want to spoil it because that's one of the fun things, right? And then you're going to take that and substitute in here. Whoa, that was crazy delayed. Okay, you're going to substitute that in there, and you'll have little mg minus whatever this thing is here, right? Equals that. So show that step. So show this step. Boom. Show these substitutions. Then show the substitution with that thing in there, right? And then solve. We got to get 4 marks out of this, right? And then the last step is solve for A. Yeah? Ta-da! Yeah, and you'll get this, I promise. Notice that they give you the answer, right? You got to show that that's the answer.